Bismillahirrahmanirrahim. Assalamu alaikum to all my dear viewers, and Alhamdulillah, my lectures are watching by some foreign students, and they requested, sir, please, if it is possible to deliver the physics in English language, then I decided to use English as a language for making the physics as an interesting subject. And the second decision which I have taken, that I make some sequence in which physics can communicate from point to point, and for that I choose A level and FSC second year, and also for the BS students course. And inshallah, I will try to complete the whole book of FSC part 2 in just 30 lectures, and I will prefer a book, Subjective and Objective Physics by S. Chand, which will be easily available on the internet. And if you are facing some difficulty in downloading, then please contact at my personal WhatsApp number, which is available at my Facebook ID, and inshallah I will WhatsApp you. And the second point is that I will not just teach you physics, I will make the physics as an interesting subject, because physics is the application of Quran Pak. And I am especially thankful to our holy prophet Hazrat Muhammad Mustafa Ahmadi Mujtaba sallallahu alayhi wa alihi wasallam, who explained the Quran Pak in a very simple way, because I am saying that either a person is liar, either the person is a physicist, because physics is totally the application of Quran Pak. In the Quran Pak, Allah Tabarak wa Ta'ala said, A'udhu billahi minash shaitanir rajim, Bismillahir Rahmanir Rahim. أفلا ينظرون إلى الإبل كيف خلقت وإلى السماء كيف رفعت وإلى الجبال كيف نصبت وإلى الأرض كيف سطحت. And you are not thinking and you are not searching about the creation of camel, and you think how the sky is at your crest point and how the huge mountains are pinned and how the land become flat for you. So inshallah I will move toward the target, and inshallah I have a target of 30 lectures to complete the FSC second part. So we will move toward the target. The first chapter of FSC second part is electrostatics. So basically electrostatics consists of two words: electric charges, and the second is in rest form. We all are familiar with the statics, that if a body does not change its position, but what is electric charge? So for this I will take a simple example, and I move from the simple concept, and I take an atom of sodium. The sodium consists 11 protons and 11 electrons, and also 12 protons. So basically we consider atom as electrically neutral particle. Why electrically neutral particle? Because it contains equal number of protons and electrons, and if I use a sum algebra for the electrons and protons, just like plus 11 minus 11, it will give me a result of 0, which means that sodium is a neutral, means every atom is considered as a neutral particle because it always contains equal number of protons and electrons. But if this sodium lose one electron or two electrons, it is not a possibility for a sodium, but if lose one electron, so when it lose electron, the electron become 10 minus 10. I just place minus for the negative symbol is used for electron and positive for protons. So here I result 10 electrons, and using the algebra I will get a positive symbol. So basically the positive mean deficiency of deficiency of electron, mean now this is not an atom, this is considered as ion. So basically ion is a species having deficiency or efficiency of electron. And I take another example. If this sodium, let's suppose, gain electron, it is not possibility for a sodium to gain electron, but I just imagine when this sodium gain one electron, it will become minus 12. So the algebra give me a minus 1. So basically this minus mean efficiency of electron. If it gain 2 electron, then I will use minus 13 and the result will be minus 2. So basically the minus symbol mean efficiency of electron and the positive mean deficiency of electron. So I will move toward the definition of electric charge. Here you have full understanding about the positive and negative. Positive mean deficiency and negative mean efficiency of electron. And when I move toward the definition of electric charge, I will take a marker. So the marker basically consists of some crystals, and the crystal also contains equal number of positive and negative poles. I just take example like this marker contain minus 50, mean 50 electrons. I just take an example, and 50 positive ions. So as a whole it will give me a 0 result, mean the marker is neutral substance. And if I take example of cloth, so basically cloth also contain, let's suppose, 100 electrons and 100 protons. So it will give me algebra of 0. So basically the cloth is also considered as a neutral particle because it contains equal number of electron and positive ions. But when I rub this marker with my cloth, so the substance having large atoms will shift electron to the other substance in which the atoms are of small size. So let's suppose if I consider the atoms in markers are of large size, so it will lose 5 electrons and will accepted by the cloth. So here the algebra will become minus 45, but the positive ions cannot move from the marker to the cloth and they will remain plus 50, and this will give me algebra of plus 5. Plus 5 mean deficiency of how much electrons, mean at the marker we observe 5 electrons in deficient, and these 5 electrons when move toward this object, the electrons become 105, but the positive charges will remain 100, and the algebra give me a -5. So -5 means the body will have efficiency of 5 electrons, and this deficiency or efficiency will be observed at its surface. So the marker has a deficiency, and I have clarified by taking the example of sodium. The positive symbol means deficiency of electron, and the negative symbol means efficiency of electron. So the marker has 5 electrons in a deficiency, but the cloth have, sorry, deficiency mean plus, and this cloth will have efficiency of 5 electrons. So due to deficiency and efficiency of electron, some property arise in this object due to which they attract or repel, and this property is called electric charge. So we can define electric charge is a property, the property which arise, the property which arise due to efficiency or deficiency of electron, and this property induce some energy in it, and this energy will compel the body to attract or repel by the other object. So I will move toward the fundamental particles as electron, which is present in the shell in atom around the nucleus, and how much charge this electron bears. So by oil drop experiment, we observed that 1 electron is equal to 1.60 10 raised power minus 19 Coulomb. Here I will move toward the definition of Coulomb, just like I have a definition of a Newton for a force, just like F is equal to ma. When 1 kilogram body accelerate with 1 meter per second square, it means the body have some external force of 1 Newton. So when I divide this term by the left side, 1 electron divided by 1.60 10 raised power minus 19, I will obtain 6.25 10 raised power 18 electrons. So how can I define 1 Coulomb? Basically, for example, if I define one team, so I can define in a manner that the group of 11 players give me a result for one team. So how can I define 1 Coulomb? Basically, the charge bears by 6.25 10 raised power 18 electrons. These electrons will collectively give me a charge of 1 Coulomb. So basically, Coulomb is a very major unit for the electric charge. But similarly, we use microcoulomb, millicoulomb, nanocoulomb in the daily life. So basically, if I have any object and it contains 3 electrons, so the macroscopic level give me a total charge, and this charge will give me N is equal to Ne. What represent the N? N basically represent the number of electrons and E basically represent charge on a single electron, and by multiplying 3 with the 1.60 it will result the total charge bears by the body. So now I will move toward the definition of electrostatics. Electrostatic basically the study of charges at rest form. I have clarified the definition of electric charge. Basically, electric charge is a property on object which arises due to efficiency or deficiency of electron. But when this charge body, for example, if I have positive body and I will bring this body to any neutral body, this deficiency of electrons will eject some electrons from this object, and these electrons will stand on the boundary and the positive ions will move toward the opposites, and these charges, this body will become charged just by bringing a charged body toward a neutral body. So basically I will observe the charge on two neutral bodies by just rubbing. But if I bring a charged body toward a neutral body and the neutral body will also become a charge, this phenomena is called electrostatic induction. Basically, induction means the charging of a neutral body by bringing to any charged body. This phenomenon is called electrostatic induction. Now after that, a Coulomb represents a very special law, Coulomb law. But here I will differentiate between law, principle and theorem. First of all, we perform some experiments, and from experimental data we will give some statement which is called law. But if I give some statement and after that I will verify my statement by some arguments or some mathematical techniques, it is called a theorem. But what is principle? Principle is basically a rule or generalized form of any statement. For example, we have upthrust force, which was already observed by the physicist, but the Archimedes principle give us some rule. If you place any object or immersed it into a fluid, this object will experience some upthrust force. So basically, principle is the generalized form of any statement. So here the Coulomb law means, for a Coulomb law, the Coulomb performs so many experiments, and I draw the table which was calculated by the Coulomb, and I take a single result, just like he take two charges, but these charges will be placed in isolated system. What is isolated system? Isolated system is basically the system in which the two bodies are not disturbed by any external force. Let's suppose I have two bodies, body A and body B, but these bodies are placed at some distance, let's suppose R, and this body have some charge Q1 and this body will acquire a charge Q2, and I have no limitation, either the Q1 is positive or negative, and the similar case for Q2. But if I draw a table for Q1, Q2 R, and these three parameters are independent, but when I observe the force between, so the force is dependent on these three parameters. So the Coulomb performed so much experiments and he reached to a statement that if I place, let's suppose Q1 as a 10 coulomb, I just a single example, and Q2 is also taken as a 10 coulomb, and the distance between them will be 5 meter. So then he observed a force as a 4 Newton. Now he will give some statement on this observation. So when he increase the magnitude of these charges, let's suppose when he increase the magnitude of these charges, he will observe a large force, and he formulated a statement that the force between these two charges is directly proportional to the multiplication of two charges. Why I cannot sum up these charges just like Q1 plus Q2? Because the rule of physics is that the similar quantities will give me a similar quantity. So when I add up charges on the right side of a relation, so on the left side I will also result as a charge, but here I will take or observe a different physical quantity. So for that we will multiply these two physical quantities, because from the multiplication and division of any two physical quantities we result or obtained a new physical quantity called the derived quantity. So and if he decrease the distance between these two charges, he observed a large force, and he will give a statement that the distance is inversely proportional to the force measured by the Coulomb. When he put all these observed values in the relation 1, let's suppose 10 multiplied 10, just like 10 multiplied 10 divided by 5 and 4. So 10 multiplied 10, 100 by 5, it will give me a result of 20. But I observed the force on the left side of relation as a force. So he was so confused that here is some confusion in my relation which does not match to my experimental value. So when he placed r square here in the mathematical statement, then 5 square, 10 multiplied 10, 100 by 25 will give me a result of 4. So then he formulated a statement that when any two charges are placed at some distance, but here is some limitations for Coulomb law. The first limitation is that, for example, if I take a distance between the center of two charges as r and the size of, let's suppose, charge A is smaller a and the size of charge B is smaller b, so the r is greater than A and B. If I decrease the distance, if I decrease this r as compared to the A and B, the Coulomb law will violate and a strong nuclear force will arise. And the second limitation is that stationary and point charges mean stationary mean these charges will be in state of rest. If I move these charges, the Coulomb law will violate. And the third limitation, these charges are point mean very small size, and this third point is also related with the point 1. So basically I think you all have understand the concept of r square, because so many students ask about the r square, that sir, why we place R square in the Coulomb law and also in the gravitational law. So here is the result, that the mathematical statement will not matches the experimental values by R. So when he used R square, then the result or the mathematical statement will totally verify with the experimental data. And let's suppose if here he observed if 3.9 Newton force, so let's suppose 3.9. So in the right side of a relation, the result is 4, but here he observed a 3.9. So 3.9 is not equal to 4. So here I will multiply some value, means 0.9, and the 0.9 will balance two sides. So after the mathematical relation, we will place or equalize the both sides by multiplication or division by a some number. So here I placed a k q1 q2 by r square. The k was not introduced by the Coulomb, but just the Coulomb was limited up to this relation, and he gave a law that when I placed some charges or two charges in any isolated system, then I observed a force which is called electrostatic force. Electrostatic force means either the force will be attractive or repulsive. The attractive will be if I placed Q1 and Q2 as opposite charges, and for same charges they will repel each other. So when he placed these two charges in some medium, just like this is A, this is B, and when this formula was given when the charges were observed in a vacuum, but when he placed these charges in any air or any other medium, he will observe the force as a 1 Newton. Means the medium will affect or oppose the force between these two charges. So let's suppose this is the force when the two charges are placed in a vacuum, and for a medium, any medium, the force become by 4 times. Let's suppose this is the force of vacuum. So I will place F medium K Q1 Q2 by R square, and I will divide the force equation for a medium by any 4. I just take example. You will divide by 4, 5, 6, 3, 2, 1. This will depend on your medium. So basically this medium will oppose the two charges, means the medium will disturb the electrostatic force. So by experimentally, means here when I multiply the 4 with 0.9, this will match with 3.9. So when Coulomb divide this side by epsilon naught and 4 pi, for a reason because these two charges are in spherical shape, the result will balance by each other. Here the epsilon naught is basically epsilon. Basically it is a Greek word called epsilon, and not mean the charges are placed in a vacuum. So basically epsilon naught is the permittivity of vacuum. Permittivity mean the vacuum will how much permit to produce electrostatic force between these two charges, and experimentally this epsilon naught will be calculated as 8.85 10 raised power minus 12. Its unit will be Coulomb square per Newton meter square, and here I will multiply 4 pi this epsilon naught by any ER. So basically what is ER? ER is just a number and called relative permittivity. A relative permittivity means how much this medium affect the force as compared to the force when observed for a same charges when placed in a space. And this relative permittivity will have no unit because it is just a number 2, 3, 4 or so much any number. Inshallah, I have advised you to use the book Subjective and Objective Physics by S. Chand as a reference book, and this book is full of so much numericals and examples. Please, it is my advice to solve the numericals by yourself, and if you face any type of difficulty, then take a screenshot of the page and WhatsApp my personal number, and inshallah I will give the explanation of your problems from 9 p.m. to 10 p.m. Take care. Allah Hafiz.